Just like we've been doing with a lot of functions this year, we have been graphing them, and then we have also been graphing transformations of them based on certain transformations and where they're located in an equation that contains whatever function we're doing at. So we're looking at logs right now. We talked about what logarithms were last lesson, and basically it is the inverse of an exponential function, and then we talked about how to switch from one form to the other, and then how to evaluate them and how to solve some simple equations with them. So graphing, okay? We also talked about how to graph sort of a basic log, and now we're going to look at the transformations, taking a basic log function, and if there's a number here, doing what to the function? What does that number here do to the function?
Stretch vertically.
Vertically stretch, and if it's negative, flip vertically. Yes? Horizontal stretch, and if it's negative, right? Yes. Horizontal shift, vertical shift. So just as, and we've been doing plenty of these this year. Okay. So what's happening in this log function? What are all the transformations that are taking place? Vertical stretch by, you're missing one word, factor. Vertical stretch, factor of 1/4, same as the value of A. Horizontal stretch, factor of 1/3, that's correct. For the actual stretch is 1/B, the value of B.
Horizontal shift to the left.
Yep. Horizontal shift to left. And vertical shift 7 down. Good. Okay. All right. Let's graph some that have been transformed in one or more ways. Now remember, with exponential functions, don't copy this down yet. With exponential functions, they look like this, and they had a horizontal asymptote. We saw last class, okay, that logarithmic was a reflection, and they had vertical asymptotes, like that. So that was log, that was exponential. Okay. So log base 3 to the x minus 1. First of all, we want points from log base 3. But remember what I said to do first? Do 3 to the x first, and then reverse them to get the log base 3. So 3 to the x, remember I said pick -1, 0, and 1. So 3 to the -1 is 1/3. 3 to the 0 is 1. 3 to the 1 is 3. But when I go to logs, remember these are inverses of each other. Inverses means switch the x and y. So reverse the x and y. we've got those already. And the asymptote is the y-axis, x equals 0, hasn't moved yet. But it looks like it's going to move with this one. So now we can do the transformation. Well, what's the mapping notation? Y stays the same, x plus 1, good. So we got to convert all those points. So 1/3 plus 1 is the same as 1/3 plus 3 over 3, which is 4/3, or 1 1/3, negative 1. 1 plus 1 is 2, comma 0. 3 plus 1 is 4, comma 1. I'll talk about the asymptote in a second after we sketch it. So these are all positive. And we've got some negatives there too, so I'll go down as well. So we got 4/3, which is about 1 1/3, which is about there, negative 1. So we're somewhere around there. Q 0. Oh, I gotta go up here. 4 1. Why does that look weird? What did I do wrong? That shouldn't look like that. Oh, that's where it is. Thank you. Good catch. There, that makes more sense. Because it's got to form a curve. Okay, so you should be able to see the curve. But what happened to the vertical asymptote from the original? It moved 1 to the right, didn't it? So if there's a horizontal shift in a log function, the asymptote is going to shift. So instead of x equals 0 or the y-axis, it moved over 1 along with all the points. So now we've got to just make sure that we're going along there. Notice the instructions also say domain, range, x-intercept, and y-intercept. What's the domain? Furthest left to furthest right. 1 to infinity. What goes around? Parentheses, right? Because we don't include 1. Because that's an asymptote. Range? Everything, negative infinity to positive infinity. X-intercept we can see right off the graph, 2. And y-intercept we can see right off the graph. Not 0. There is none. It never hits the y-axis. It goes along here and keeps going down forever, so none. See if you can do the next one. Okay, see if you can do the next one. Remember, if there's no base on the log, we assume it's 10. So just to give you that as a bit of a lead. Log x is the same as log base 10 of x. So you should be getting 3 points from 10 to the x or y to the x. Okay? which are -1, 1/10, 0, 1, 1/10, and then they all get reversed when I reverse the log. So 1/10, -1, 0, 1. Sorry, I gotta flip those. 1, 0. And what's that? Oh, x, y plus 2. So let's do, we got 1/10, 1, 1, 2, 10 plus 0, 3. So let's see, we gotta go 1, 2, 3, 4, 5, 6, 7, 8, 9. I gotta go at least 10 out there. Gotta go 1 down here, 1 up here. So 1/10 comma -1, that is really close to the y-axis at -1 for y. One, 2.
Yeah.
What am I doing?
That's negative. There's a negative one.
1/10 -1. Oh my. I completely flipped it wrong. Reversed it. -1, 1/10. What's wrong with you?
No.
Are you serious?
1/10 and.
Wait, it's transformed. Stop messing with my head. I had it. Did I not have it?
Yeah, you had it. You were drawing it wrong.
I was drawing it wrong.
It's 1. It's 1. It's 1 plus 2.
Just like brain farts today. Anyway, sorry, we're up here. I was wondering about that. Because I thought, no, it looked almost like a stretch. And that's just crazy. Anyway, 1, 2. Now I'm on. Now I'm good. And then 10, 3. So notice there was no horizontal shift, so the asymptote stays at x equals 0. That's a very sharp turn. So this remains at x equals 0. Domain? 1? 0 to infinity, with a parenthesis around 0. Because it does start at 0, but doesn't include 0, but really close. Range, everything again. Before I get to the x-intercept, the y-intercept, none, because it never touches. The x-intercept, it's going to be really hard to read it off the graph. Obviously, it's very, very close to 0. Okay, so the only way we could really do this is algebraically. Remember, to find the x-intercept, we make y equals 0. So therefore, we're going to have 0 equals log, and remember it's base 10 of x plus 2 Move the 2 over to get -2. How can we figure out what x is? Change it to exponent form. What does this look like in exponent form? Remember how to change it? 10 to the -2 equals x. Because base becomes base, answer to the log becomes exponent, and then argument becomes answer to the exponent. And what is 10 to the -2? 1 over 100. So it would be very rare to get a question like that. Okay? Where you have to figure it out algebraically. Most times you're going to be able to read it off the graph. Okay, but I did want to show you one where it's like that. Okay, last example, we're doing a bit more to this one. What do you want to do first? 2 to the x. Remember, inverse of this is just 2 to the x. So we get -1, 1/2, 0, 1, 1, 2. Reverse them to get the log. Nice. So now we've got the points for the log base 2. Now we have to do the mapping notation. X minus 1, -3y is correct. (1/2) subtract 1. (1/2). Remember, 1/2 subtract 1 is the same as 1/2 subtract 2 over 2, which is -1 over 2. And then multiply these two to get positive. These last two are pretty straightforward. We get 0, 0. And we get 1, -3. There was horizontal shift, which means the asymptote's going to move. But let's plot the points first. So we have got -1/2, +3. So up there. Zero, 0, and 1, -3. So it is sort of a very gentle curve. Now the question is, where's the asymptote? At 1? -1 is correct. That's right. So that sort of tells you which one you draw off like that, and then which one you draw along the asymptote to finish. So yes, because of the horizontal shift, the asymptote shifted 1 to the left, so it became -1. Okay. And we've seen sort of the domain and range has been pretty straightforward. This one is -1 to infinity, but a parenthesis around the -1 because we don't include it. Range is everything again. X-intercept. Y-intercept. Good. Okay. Okay.